In this question, a beam AB is given 6 meter long and the load acting on it is also as shown in the figure. Okay. Now we have to find the reactions at A and B. Right. So here at A there is a hinge support given, and at point B there is a roller support given. So let's first draw the free body diagram. We all know the different types of support. There is fixed support, hinge support, roller support, etc. So we also know the corresponding reactions. So here we have the hinge support. We shall draw the reactions for hinge support at end A, right? So here we are drawing the reactions at hinge support, right? So here there is RAY and RAX, right? RAY in the vertical direction, RAX in the horizontal direction. So we have drawn that. Now at end B we have a roller support. So we know the reactions for roller support also. It will be in the vertical direction. Let's name it RB. So here I have marked the reactions at both the supports in blue color, RAX, RAY at end A and RB at end B. Now here we have 10 kilonewton acting downwards and 20 kilonewton acting here. Okay, so for this to solve the problem we have to transfer this 20 kilonewton to point C. This is point D, this is point C. AB is the beam. So we have to transfer 20 kilonewton to this point C. For that we convert it into force plus moment at point C. To transfer this force 20 kilonewton acting here to point C, we first draw a force 20 kilonewton, okay? A force downwards. Same as this 20 kilonewton, we transfer it to point C and mark is 20 kilonewton. And the moment here, okay, this is 20 kilonewton and the perpendicular distance between the point C and the line of action of force is 2 meter. Okay, between the perpendicular distance between the point C and the line of action of this force is 2 meter. So transferring the moment to this point C point, we have 20 into 2 acting in the clockwise direction because the force is acting in the clockwise direction towards C. So 20 into 2 is 40 kilonewton meter in the clockwise direction, so it is positive. So we have transferred this force 20 kilonewton to this point C. So it will be in the form of force plus moment. Force plus moment. The force 20 kilonewton is acting downwards at point C. And the moment is 20 into 2 is equal to 40 kilonewton meter in the clockwise direction. Right? In the clockwise direction. Right. So this is the free body diagram that we require. Now we can apply the equilibrium equations is equal to 0, right? So we have here only one RAX in the horizontal direction. So that RAX will be 0. Now let's take the equation sigma Fy is equal to 0. So sigma Fy is equal to 0. We have RAY acting in the upward direction and RB acting in the upward direction. So RAY plus RB minus 10 kilonewton is acting in the downward direction. 20 kilonewton force is also acting in the downward direction at point C. So that is why RAY plus RB minus 10 minus 20 is equal to 0. Right? So that is RAY plus RB is equal to 30 and we take this equation as 1. Equation 1. Now let's take sigma M is equal to 0. So here we are taking the sum of moments with respect to, let's say, point A. With respect to point A, we are taking the sum of moments and equating it to 0. So let's find the moments with respect to A. Considering the free body diagram, we can find RAX and RAY are passing through this point A. Right? So there will be no moment caused due to these reactions. Now 10 kilonewton is acting at a distance of 2 meter from A and it's moving in the clockwise direction, right? clockwise direction with respect to A. Always remember, we are considering the moment with respect to point A. So 10 kilonewton, 10 into the distance between the force and the point A is 2, and clockwise direction, so that is positive. Now we have 20 kilonewton at point C. Again, this whole distance from A is 2 meter plus 2 meter. This entire distance AC, 2 plus 2, that is 20 into 4. Is it plus or minus? We can see that towards the point A, 20 kilonewton is moving in the clockwise direction. So again, it's positive. So positive plus 20 into 4. Now we have this moment already acting at point C, right? It's kilonewton meter positive. That's clockwise direction. So we just add plus 40 because it's already moment. It's already moment. Now we have RB remaining. RB, the distance between RB and A, this entire distance is 2 meter plus 2 meter plus 2. That is, this whole AB distance is 6 meter. And we can see that RB is moving like this with respect to point A. It's moving in the anti-clockwise direction. So that is negative because RB is moving in this direction, that is anti-clockwise direction. So that is minus RB into total distance AB distance is 6 is equal to 0. So from this equation we can see that RB is the only unknown and we can calculate the value for RB. So here RB is equal to 23.33 kilonewton. We can substitute this value for RB in equation 1 and find RAY. So here I have substituted the value for RB 23.33 kilonewton in equation 1. So I can find RAY is equal to 6.67 kilonewton. We already know RA is equal to root of RX square plus RAY square. So I've already found out RAX is equal to 0 and RAY is equal to here 6.67 kilonewton. Substitute the values, we get the reaction at A 6.67 kilonewton. So these are the values or reactions at A and B, RA and RB. Thank you.